All right, guys. So I hope you enjoyed the snow day. We wanted to give you a quick look at some of the things that are fair game on the summative tomorrow so that you feel reasonably prepared. Now, this first one, just be prepared for some questions that look kind of like this, where you're going to have to graph two linear inequalities, such as this, and tell us what is and is not a solution. Now, please remember, solutions to linear inequalities are things like this. If we're looking here, solutions to the linear inequalities are going to be within sort of this double shaded region. Now, if you are doing this properly, the double shaded region should be fairly clear. Now, you don't need to use different colored pens or ink or anything along those lines, but you can use differences in the firmness with which you're shading. So anything in that red area would be a solution. Anything in these blue areas is not a solution to the system. So any of those would be not solutions, and any of the others would be solutions. Now, we're going to come down to the second part. Shout out to our friend Deep here. Deep wants to buy pizzas and sodas for a party. He can spend no more than $50. And I'm going to underline and circle that. Pizza costs $8 and soda costs $8 and soda costs $2. The let statement is already here. Let X represent sodas and Y represent pizza, right? The inequalities represent this situation. Well, when I'm doing this, we remember that I want to set my goals here. What am I trying to do? Well, I want to buy sodas and pizza. I cannot spend more than $50. So I have a money equation. And then when I look through, I ask myself, are there any other limitations I have? And there's not. There's no other limitations that I need to be worried about. There's no number of things that I need to buy or anything like that. So this isn't even a system, which is nice because that tells me all I need is one inequality. This is the easiest way to do this, is read through and say, what are the limitations? What are the goals that I have here? Well, I know that sodas are X, so 2X plus 8Y cannot be greater or must be less than $50. So right here, this is our inequality. And this is the situation for Deep's party right there. So now we're going to go over a couple systems, how to solve them, and things along those lines. So looking here, when I see this, I personally see that we have an isolated variable. So I'm going to use substitution. You could eliminate, but it would be way more difficult in this case. So we're going to substitute. So I say, great, 2x plus, well, I know what y is, and I'm going to input that here. Y is 2x minus 4. All of that equals 16. Well, once I do this, there's no negative, so I don't have to distribute anything. I say 2x plus 2x minus 4 equals 16. 4x minus 4 equals 16. 4x equals 20 because I added 4 to both sides, and therefore x equals 5. Now please remember, we are not done. We only have x here. So now I'm going to, if I can get this to pop down, I'm going to say, great, well, y is equal to 2 times 5 minus 4. So y equals 10 minus 4, therefore y equals 6. And then finally, I must write it as a coordinate. So 5, 6. So that's the answer to number 4 there. Now we're going to erase this, free up a little space here. And I say, great, now what I'm looking at is two equations in standard form. I know they're in standard form because x and y are both on the same side of the equal sign. Therefore, I personally am going to eliminate. You could substitute here by simply moving either this x or this y, but it seems like more effort than I feel like putting in. So I notice that x and x have the same coefficient, a coefficient of 1, and one is positive and one is negative. So I'm going to add. When I add, x eliminates, I get 2y equals 16, therefore y equals 8. And then I know that x plus 3 times 8 equals 15. So I know that x plus 24 equals 15. So x equals negative 9. And then I write it as a coordinate, negative 9, 8. Now, if I want to graph this inequality, we're going to go over this because this has been kind of killing us lately. I have y is greater than. I notice it is not equal to. It is just greater than, so it's going to be a dotted line. It is greater than negative 2x minus 2. So y is greater than negative 2x minus 2. I'm going to go down to over 2. And it is a dotted line, which I'm going to represent like this. And then it is greater than. So I'm going to find any point on the line, draw an arrow upward, and shade that side. And what would a solution be? Well, an easy solution, I would say, would be 2, 2. Now we're coming down here. Hopefully this should be reasonably simple as well as this. The last one I want to give you a quick heads up on is to show you number 8 really quickly, and then I'm going to give you some of the sample questions that you can look through on your own, but so you're not wasting all of your time watching this video, you can do that. So what is x plus y? These are the questions that kind of kill us because we expect when we hit the end, when we get a coordinate, we're done, and that is not the case here. This is also kind of a hefty question because I look at my coefficients and neither of them look particularly friendly. So because of laziness, because I already see that 6 and 4, my y values, are already opposite, one is positive, one is negative, I'm going to multiply the top by positive 4 and the bottom by positive 6. Now I want you to see what that gets me. By multiplying this top equation by positive 4, I get 24y minus 32x equals 16. And then this bottom equation, I get negative 24y because I multiplied by 6 minus 18x equals negative, let me find my eraser here. Negative 36 times 6, I get 6, 3, 18, negative 216. There we go. Now, once I do this, I'm going to add my y's eliminate. Adding these two, I get 50x negative 50x equals negative 200. Therefore, x equals 4. Well, once I have that, I'm not going to use either of these. These are nightmares. I'm going to take this and input it into this equation. So I'm going to say 6y minus 8x equals 4. Well, what is x? Well, 6y minus 8 times 4 equals 4. Therefore, 6y minus 32 equals 4. And from that, I get 6y equals 36, and therefore y equals 6. Here's the place that we can't get tripped up. What was the original question? What is x plus y? Well, what is 4 plus 6? that equals 10. So my final answer for that is 10. Now, there are a couple other word problems that I'm going to show you how to annotate and set up, but hopefully you should be able to solve them on your own. And then you should be good to go. Now, looking through here, we're going to start here. Actually, we're going to do number 10 also, just so you can get a reminder of how to solve a system with 3 variables. We're going to come over here, paste, great. Now, when I'm looking at this, I need to remind myself of what I'm doing here. I want to get everything down to 1 variable first. When I'm strategizing through here, I look at my x's. Those don't look nice because they're 3 different coefficients. Y looks super convenient, but let me just check my z's. Z's look terrible. So I'm going to do this. I'm going to break these down into what I've dubbed the red and blue equations. Please remember these are not technical terms. This is just how I help you see it. So I get 4x minus y plus z equals 20. And negative x plus y plus 3z equals 8. And now I see that my y's are opposite of one another, so I eliminate by adding. So I get 3x, because that's a negative x, plus 4z equals 28. And then here I have negative x plus y plus 3z, because I'm using these 2 equations now, 5x minus y minus 5z, and I'm going to add, oh, I forgot the equals 8 and 0, my goodness. So when I add, I get 4x, that eliminates, minus 2z equals 8. And then I come over here and I put both of these together. So I'm going to say 3x plus 4z equals 28. And then I see that the z's are going to be the easiest to equalize. So I'm just going to multiply, just so you see what I'm doing. I'm multiplying this whole thing by 2 when I bring it down. So I say 8x minus 4z equals 16. I only did that because I saw that in order to equalize my z's, I would need to multiply by 2. I could have equalized my x's, but that would have required multiplying both equations, and I don't want to do that. So here we go. These are opposites, so I add, I get 11x. That eliminates, equals, well, that's going to be 14, 44. So x equals 4. Now, I take that x and I start to work my way back upwards because I now have 1 variable. Once I have that, I'm going to choose one of these 2 equations to work with. I'm going to use the red one just because I chose to. So 3 times 4 plus 4z equals 28. 3 times 4 is 12 plus 4z equals 28. 4z equals 16 and z equals 4. Now I have 2 variables and I come back up to the top. This one looks the easiest. I could use any of the 3, but that one seems the simplest. So I'm going to say, great, negative 4, because that's x plus y, plus 3 times z, which in this case, I'm sorry, is 4, equals 8. Now, I simply combine these. I get negative 4 plus y plus 12 equals 8. I combine those and I get 8 plus y equals 8, and therefore y is 0. So my final answer is 4, 0, 4. And again, just to reiterate exactly what was happening there, I found one of my variables by combining two of these equations and eliminated. After I did that, I eliminated another remaining variable and ended up with one variable. From there, I worked my way back upwards to the two variable equations to find the second variable, which was z. Finally, once I have two of those, I choose one of the three variable equations and solve for the final variable. Now, there are a couple other questions. I'll leave them on here. If you do have any questions, feel free to send me an email. Feel free to send me an email about how to do this. But these are just some examples right here that I'm highlighting of some of the questions you might see on the summative. All right, guys. I'm going to end this video now. If you do have any questions, please, please, please feel free to reach out. Let me know. I will be available via email until probably around 10-ish this evening, as well as tomorrow morning. I wish you all the best. I hope you are having a fantastic snow day, and I'll talk to you later.